Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. Picture this. It's GCSE paper season, heart racing, and a student cancels 2x plus 3 with x plus 1 and confidently writes the final answer. The examiner shakes their head and deductions start to add up. That single slip cost 2 marks on a question worth 3. Sound familiar? You're not alone, and today we stop that error for good.
Ouch, I think I've done that. So this episode is about stopping that exact mistake?
Exactly. We'll focus on algebraic fractions, what they are, why you must factor first, how to add, subtract and solve equations involving fractions, and most importantly, how examiners award marks so you can grab them. Let's work through this step by step.
First, what is an algebraic fraction? It's just like a number fraction, but the top, bottom, or both contain algebraic expressions. For example, 2x plus 6 over x plus 3 is an algebraic fraction. The key idea is that you can only cancel factors, not terms. That distinction is everything. Step 1. Factor completely. In our example, 2x plus 6 factors to 2 bracket x plus 3. So 2x plus 6 over x plus 3 becomes 2 bracket x plus 3 over x plus 3. Now you can cancel the factor x plus 3 because it's a common factor in numerator and denominator. The result is 2. That's the correct cancellation. Notice we cancelled x plus 3, a factor, not x with x or numbers inside terms.
So cancelling is okay after factorising fully, not before. Got it. But what about expressions that don't factor nicely?
Good question. If it doesn't factor, you often need a common denominator to add or subtract, or you might have to rearrange to a single fraction before solving. Let's do 2 short worked examples, one simplification and one equation, so you can hear the reasoning behind each step.
Example A. Simplify. 3x over x squared minus 9. First, spot the denominator is a difference of squares. X squared minus 9 equals x minus 3 multiplied by x plus 3. No other factor in numerator except 3 and x, so write 3x over x minus 3 multiplied by x plus 3. There's nothing to cancel unless x equals one of those factors, so this is already simplest form unless the numerator shares a factor. If x is a variable, we leave it as 3x over x squared minus 9, or we note the factorization as the final step, 3x over x minus 3 multiplied by x plus 3. Write the factorized form. Examiners love to see it.
Example B. Solve. X over x minus 2 plus 2 over x plus 3 equals 1. First step, find a common denominator, x minus 2, x plus 3. Multiply each term appropriately. X plus 3 over x minus 2 x plus 3 plus 2 x minus 2 over x minus 2 x plus 3 equals 1. Combine over the common denominator x plus 3 plus 2x minus 2 over x minus 2 x plus 3 equals 1.
Next, expand the numerator. X squared plus 3x plus 2x minus 4 equals x squared plus 5x minus 4. So we have x squared plus 5x minus 4 over x minus 2 times x plus 3 equals 1. Multiply both sides by the denominator, but pause and note the restrictions first. X cannot be 2 or negative 3. Always state exclusions. Now multiply. X squared plus 5x minus 4 equals x minus 2 times x plus 3. Expand the right-hand side. X squared plus x minus 6. Then bring all terms to one side. X squared plus 5x minus 4 minus x squared minus x plus 6 equals 0, which simplifies to 4x plus 2 equals 0, so x equals negative a half. Finally, check that negative a half is not 2 or negative 3, safe, and substitute back to confirm the original equation holds. Don't skip that check.
That was really clear. I like that you said state exclusions. I always forget domain restrictions under time pressure.
That's part of exam technique. Let's shift to how marks are awarded, so you know what to write down. For a 3-mark fraction question, you'll often see M1 for setting up or factorising correctly, M1 for applying the correct common denominator or operation, and A1 for the correct final answer in simplest form. For a 4 or 5-mark question, there's typically an extra M1 for algebraic manipulation or stating exclusions. Example marking breakdown for the equation we just did. M1, common denominator setup, M1, correct combined numerator, M1, correct multiplication and rearrangement, A1, correct final value of x with exclusions stated. If you make an algebra slip after a correct setup, you can still earn the first 1 or 2 marks. That's why write it down, don't just think it, is crucial. The examiner wants to see your method.
So even if I get the arithmetic wrong at the end, I can still salvage method marks if I've written the steps clearly.
Exactly. Marks are there for the taking. Now, here's your quick win, a simple checklist you can do in under 30 seconds during a paper.
Quick win checklist. 1. Factor completely first. 2. Cancel only factors, not terms. 3. Rewrite as a single fraction before solving. 4. State domain restrictions, values that make any denominator 0. 5. Substitute your answer back into the original equation. That 10-second check catches 90% of silly errors. Don't skip the check.
That substitute back tip has saved my homework more than once. 10 seconds and peace of mind. Now, a short deep dive into the common cancelling mistake. Students often cancel parts of sums. They see 2x plus 3 divided by x plus 1 and cancel the x or the plus 1 as if they were factors. That is wrong because 2x plus 3 is not equal to 2 times x plus 1. There's no common factor. To show why it fails, take a specific x, say x equals 1. 2 times 1 plus 3 divided by 1 plus 1 equals 2 plus 3 divided by 2 equals 5 over 2. If you cancelled wrongly, you'd get 2 divided by 1 equals 2, which is not 5 over 2. A quick substitution like this during checking will spot the error immediately. How to spot the error quickly when marking your own work or a peer's? Look for cancellation signs and ask, did they factor first? If you see cancelling across a plus or minus sign, flag it. Write factorise in the margin and force yourself to rewrite the line as factors. It's a small habit that prevents big mark losses.
Could you give 2 practice questions we can try now to cement this?
Practice prompt. 2 short questions. Question 1, simplify, 2 minutes. Simplify 4x squared minus 16 over 2x minus 8. Write the factorised form and the simplified result and state any exclusions. Question 2, solve, 6 minutes. Solve x plus 1 over x minus 2 equals 3 over x minus 2 plus 1. Show the common denominator steps and exclusions. Timing advice. Aim for 2 minutes on the simplification and up to 6 on the equation. Even if you don't finish, write the factorisation and common denominator. Those are method marks. Write it down, don't just think it.
Answers are in the show notes with full worked solutions. Try them now, then check your working against the notes and use the 10-second substitution check to confirm your solution. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.